class, here is a quick video on how to use the graph of a polynomial equation and the x-intercepts of that graph to factor a polynomial. So I'm trying to factor the polynomial 4x cubed minus 12x squared minus 19x, not 13x like I tried to do in class, plus 12. And the way we're going to do that is we're going to find the factors by looking at the intercepts of the graph. So I look at the intercepts of the graph. There's the graph y equals 4x cubed minus 12x squared minus 19x plus 12. I see the intercepts are negative 1/2, which is, sorry, negative 1.5, which is negative 3/2, positive 0.5, which is 1/2, and positive 4. So my factors should end up being something like x plus 1.5, x minus 0.5, and x minus 4. Because that way, I got a 9 there, so I'll go parentheses 1 second. Right, that way, all of those values of x, negative 1.5, positive 0.5, and positive 0.4 will make this equation equal to 0, which is equivalent to being where an x-intercept would be. The only thing here is that if I multiply out this factoring here, I won't actually get 4x cubed. I will just get x cubed. So what I actually need is a factor of 4 in there. Oops, not there though, I need it out in front. So this would technically be correct. 4 times x plus 1.5 times x minus 0.5 times x minus 4, but it doesn't look very nice, right? I'd rather not have decimals. So what I'm actually going to do is distribute that 4. Well, I'm actually going to break the 4 up into 2 times 2. Let me copy this. Let me paste this. I want a 2 times that first factor. Basically, all the factors that aren't nice integer pieces, like the factors that have non-integer numbers, I want to make them integers. So now if I do that, the 2 times x plus 1.5 will give me a 2x plus 3. Right, so 2 times x plus 1.5 is giving me 2x plus 3. 2 times x minus 0.5 is going to give me a 2x minus 1. And x minus 4 is still perfectly fine as x minus 4. So now we have actually factored the original polynomial 4x cubed minus 12x squared minus 19x plus 12 nicely as 2x plus 3 times 2x minus 1 times x minus 4. And we can definitely see that if we were to set this equal to 0, then the solutions would of course be the solutions we found on the graph over here. We would have, we would have x equal to 3/2. I'm going to write the fractions the lazy way. We would have x equal to 1/2, and we would have x equal to 4. Which I know we got from graphing it, but if we just had this factoring, sorry, and that should be an x equal to negative 3/2. Apologies, slight mistake there. There we go. X equal to negative 3/2, x 1/2, x equal to 4. So there's this very, very nice correspondence between knowing what an x-intercept of a function is and knowing what a factor of that polynomial is. All right, that's all I got. I will leave it there.